Welcome back to 3 Inquisitive Kids. In the last video, we had our introduction to factorization. And in this lesson, we will be discovering one way that we can conduct factorization, which is by removing common factors. Removing common factors from numerical expressions has been something that we've done before. Now, we're going to do this with monomials. This is part 1 of our lesson, Removing Common Factors. Part 2 on polynomials will be coming up soon, so if you would like to be notified for that, please make sure to hit that subscribe button and the notification bell as well. That way you won't miss the next time we upload. Anyways, here is our learning goals. Able to identify common factors, paying attention to sign when removing. The sign is whether a term is positive or negative. And 2, factor polynomials by removing common factors. Here's our introduction. What are the terms of polynomial MA plus MB plus MC? Well, that would be MA, MB, and MC. And what are the factors of each term? Well, that's asking for how is each term made up by, using multiplication. That would be M and A, M and B, and M and C. And question 3, are there any common factors among these terms? And if so, what would be the common factor? Well, what's the factor that each of these terms share? That's M. So, yes, they do have a common factor, and it is M. Please list the common factors in the polynomial ab squared minus 2a squared b. Well, the common factors would be a, b, and then multiply together, which is ab. The common factor is basically the factors of a term that is shared in all of the terms of a polynomial. Determining the common factor. What is a special feature of this polynomial right here? PA plus PB plus PC. Well, we can see that each of these terms have the letter P, have the variable P. So this would be the common factor. We call the same factors contained in the terms of a polynomial the common factors of the terms of the polynomial. Now let's find the common factor for this expression, 3x squared minus 6xy. Well, the first thing I like to do is to expand each of these terms. For example, for 3x squared, I would do 3 times x, just writing it out. And then I have negative 6xy, which is equal to negative 1 times 2 times 3 times x times y. So here, what are the factors that are shared in both of these terms? Well, that would be 3 and 1x. So 3x would be the answer. The coefficient part of the common factor would be 3, and that is always the greatest common factor between the given coefficients. The variable part of the common factor would be x. The variable would be the same variable that appears in each of the terms. And then finally, what would be the index or the exponent for that variable? It would be 1 because we're looking for the lowest exponent of that same variable in each term. Therefore, the common factor would be 3x. Knowledge checkpoint. The key to correctly finding the common factors of polynomials is, first, to find the coefficient. The coefficient of the common factor is always the GCF, greatest common factor, of the coefficients of the polynomial. Then we have to find the variable, which is the variables contained in all terms of the polynomial. And finally, the index of that variable, which would be the lowest exponent of the same variables. Again, this also will seem less complicated once you expand each term. Let's do a quick exercise. Find the common factors of the following expressions. Now I want you to pause the video and use the expanding method we just looked at to solve these 4 questions. The first one would have a common factor of x. since that is shared in each of these terms. The next one would be A, and then this number 3 would be B. And it's not AB because in the second term, it does not contain, and so the common factor must appear in each of the terms. And for the final one, it would be A. So here is the concept that we are aiming for, the common factor method. Usually, if the terms of the polynomial have a common factor, the common factor can be factored out. This is one way of factorization, called the common factor method. So this is just one way of factorization, whose definition we learned in the previous lesson. Factorization, there are many other ways to do it, and the rest of the lessons of this unit will be focused on the other ways of factorization. So here in PA plus PB plus PC, P would be our common factor, and we can factor that out to have P times the sum of A, B, and C. Factor 8a cubed b squared plus 12ab cubed c. All right, so did you expand? Let's first expand both of these terms. We have our first term, which is equal to 2 times 2 times 2 times A times A times A times B. And our next one, our second term, is 12a b cubed c, which is equal to 2 times 2 times 3 times A times B times B times B times C. So now we can look at which factors do both of these terms share. Well, I see a pair of 2, another pair of 2, a pair of A's, and a pair of B's. So multiplying all of these together, so 2 times 2 times A times B will have 4AB. Here's our analysis. Steps of finding the common factor, which is 2 steps. First step, identify the common factor, and then we remove the common factor. So pretty simple. Here is our solution. Since we already found out that the common factor is 4ab squared, then we can take that out, and then we have 4ab squared times 2a squared plus 3bc. So if 4ab is removed, is there any other common factor left? You must think, if you just removed 1b and didn't have that squared right there, is there any other common factor left? And if so, you also have to remove that. So when you're removing common factors, you must make sure that you are removing it until there is no more common factor. The remaining portion of this expression still will have a common factor of b. The following is the result of 3 students who each tried factoring 2x squared plus 4x. So which student had the correct result? Well, let's talk about this. We can do multiplication to check the results. But after doing multiplication, we'll see that they are all the same. But where should we pay attention to when removing common factors? Let's look at how one student factored this expression right here. The original equation was equal to 3xy times 4x plus 6y, so the common factor was 3xy for the student. But actually, this is incorrect. Why? Because the common factor hadn't been fully removed yet, for another 2 can still be removed. So the correct solution would be 6xy times 2x plus 3y. Notice that the common factor should be moved completely until there is no more common factor left. Now here is another student's solution. She is being asked to factor 3x squared minus 6xy plus x. This is her solution, x times 3x minus 6y. Again, this is incorrect, because when the term of a polynomial is the same as the common factor, the remaining term after removing the common factor is 1. So what this is saying here is that this student, she thought that since this last term, x, was already removed, she could just delete that term and not think about it. Well, actually, x is equal to x times 1, so she still has to have a positive 1 parentheses. So the correct answer would be x times 3x minus 6y plus 1. Notice that a term can be removed to become 1. So if you think that you fully removed a term, you still have to write a 1 in its place. Now here is the final student's solution. So Kaylee is being asked to factor negative x squared plus xy minus xz. And her solution is negative x times x plus y minus z. And this is incorrect as well. Right now we're showing you some common mistakes that students make when trying to remove common factors. She did not switch the signs of the terms after removing the negative sign. So after taking out a negative sign, or if you think about it, taking out a negative 1, you have to make sure to change the signs. So she did do that for the first term, but not for y and for z. So the y should become negative y and the z should become positive z. So the correct answer should have been negative x times x minus y plus z. So notice that if the first term has a negative sign, the common factor would be negative, and you have to pay attention to switching the signs. Let's do another example. Factor these 4 expressions. Use the skills we've just learned and watch out for the common mistakes when you factor these expressions. Well, here is our first solution. After taking out the common factor of x, you should have x times 3 plus x squared. For 2, after taking out the common factor of 7x squared, you have 7x squared times x minus 3. And then you have the third question where you're taking out the common factor ab. And then after taking that out, you should have 8a squared ab times 8a squared b minus 12b squared z plus 1. And for the final one, number 4, the common factor should have been negative 4x, and your answer should have been negative 4x times 6x squared minus 3x plus 7. Class summary. Today we removed common factors, and we first removed common factors that are monomials. In the next video, it will be about polynomials. So we learned about identifying common factors and the 2 steps to removing common factors. And we also went over some common mistakes that can happen. First, we have to remember to remove the greatest possible common factors. Second, when you think that a term is completely removed, it becomes 1. And third, we need to pay attention to changing the negative sign. Again, today we were able to identify common factors while paying attention to the sign when removing negative numbers. And we were also able to factor polynomials by removing common factors. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.